Yes,
Should I
Ashudeep, you
start?
can start off. Yeah.
Okay. Okay. Hello, everyone. Good morning to the folks in US and good evening to the folks in Asia Pacific region. I am Ashudeep, and I'll be presenting this Developer Week session on From Concepts to Code, leveraging AI through ColdFusion. A bit about me: I'm Ashudeep Sharma. I'm a senior computer scientist at Adobe. I have around 8 years of around 8 years. I'm associated with 8 years with ColdFusion team, and I've worked primarily on language, ORM, CF query, database, and GraphQL. And overall, I have around 14 years of experience, mainly having experience on building distributed systems to query engines to application development. And yeah, since last 6-7 years, I've been working in compiler stuff as well. So that's a bit about me. And let's go for the agenda today. So today we have uh, these four things in the agenda. Like, we'll be going through generative AI, then we'll go through a bit of understanding of LLMs, that how these generative AI models, or what you call as Gen AI thing works. We'll discuss a bit about prompt engineering, about vector stores and RAG. But before starting the session, right, there is a thought process that comes into everyone's mind, that there's so much spark about Gen AI. Everyone is trying to do something on Gen AI and all, right? So what Gen AI is all about, right? So some thoughts come into our mind whenever we look forward towards sessions and all, that what we are going to learn through this session and all. So the thought, uh, like, before making this presentation, that I had was that few things that should be conveyed properly is like, is querying information from LLMs using ColdFusion possible? Then can we ask LLMs to answer queries which are not related to the information on which the model is trained? Because LLMs are basically large language models, right? They are trained on certain data, but can we get LLMs to answer on certain queries which is not related to the data that they are trained on? And then, can LLM answer queries related to private documents if someone has their own private documents which they don't want to share in public, and still wants LLM to answer those? And more importantly, can we do it using ColdFusion, right? So let's talk about generative AI. So what is Gen AI, right? Gen AI refers to AI models that can generate new content. The content can be text generation, images, music, and video. It is basically being used for summarization. These are being used for as conversational bots as well in the customer support domain. Then, if you want to do some question and answers in certain documents, and also on creative design, like if someone wants to create some images, videos, and all. And then we keep on hearing this term LLMs. What LLMs are? So LLMs are large language models, and these are artificial intelligence models which are trained to understand and generate human like text, right? So some of the popular LLMs that we have heard about is GPT-4, which is being created by OpenAI. Use cases are like chat gpt, coding, writing. Then there is Claude model. We have Llama from Meta, Gemini from Google DeepMind, right, which is used for multimodal and search use cases. And then we have some open source models as well, like Mistral. And these are basically for local models if you want to train something on the data that is not public as well. So yeah, so there's this case of Gen AI. Then the question that comes into our mind is that Gen AI exists now. How should I go on with a hands-on session, or how should I start playing with Gen AI? So basically, there are some portals which you can do. Okay, you can query those and query those URLs and all. And the other things, the simplest things that you can do is that you can download LM Studio, which is a desktop application that allows you to run and chat with the open source LLMs locally on your machine. And for that, like, no internet or cloud is required when you are just trying to query them, right? I mean, so there's no need of internet. The only thing that you are required is, once you download this LM Studio and download the model, and that's it. You can play it with it offline. Some of the prominent features for this are like running LLMs locally, so you can download some models and run those models. It has a nice chat interface, which we are going to see. Then it has model downloader. So basically, you can download a model, you can search for a model here, and then you can download it and load it. It has custom system prompts as well, so you can just write some prompt and it's going to answer in that format. It has its own API mode. So basically, when you load a model and you start the server, it basically runs on, it exposes an API which you can use. So now, like in this, some local host 1234 even chat completions is the API that has been exposed. So this you can use for querying. And yes, it has the offline capability. It is more sort of, it has this own settings as well, that if you want to tweak the parameters, or what is the context length and all, but it has a nice UI representation which you can use. Then we have something called as Olama, which is a very lightweight free open source tool that can run LLMs on your local machine. It's just a one line setup. So you just do Olama download the model name, and Olama run the corresponding models. So it runs LLMs like Llama 3, Mistral, Gamma 5 locally. It has a chat interface, so it's like a command line interface. You just type some questions and it's going to answer that. It's very simple to set up, and it is great for RAG, which we are going to discuss what RAGs are all about, and local LLM pipelines. And yes, it do have that offline capability. So once you have the models downloaded and once you have loaded them, there's no need to be connected to the internet. You can play it online, offline as well. Now, these were two ways that you can do, but apart from that, there is also another way, which is like using ColdFusion, right? So there's a sample code that we have. So we have CF tag, in which we can just run these LLMs locally on our machine. And then using some applications, using a CF application also, what we can do is we can point it to the corresponding API that we mentioned. Then we give some kind of request, and in request we have model name. So model name is basically the model that it needs to load, and the model from which we are querying. And then there is a prompt which we are going to discuss, like what prompts are all about. And in prompts also there are various roles. So there is a system role as well as a user role. System role is basically to make an understanding to the LLM that how you are going to answer this question, right? There should be certain way, there should be some format, you need to be polite, or some kind of prompts, custom messages you can give. And then in user role, you have the corresponding query, that is what is you that you are going to ask to the LLM, right? So like in this, I have just asked describe yourself in one paragraph, okay? And then just I have created a request, and I have just posted it at the LLM exposed endpoint, and I'm getting a response, and I'm deserializing it. And this is what the LLM response I'm getting, that it's just saying that I'm a large language model created by Google AI, and a bit about that information. And you can be precise as well. Next, coming to LLMs, right? So what are these large language models? Okay, so LLMs are basically large language models that are trained on huge data sets. These can be books, these can be a web corpus, articles, using self-supervised learning to predict and generate the natural language. So basically, if you give some text, it will predict what the answer or what the next text would be all about these things. It has the concept of tokenization. So basically, whatever we do, so it just doesn't deal with text directly for the comparison, because machine understands only like numbers and all. So that text is being split into a big text is being split into tokens, and these tokens are then converted to some values, and using that it is being applied in the transformer architecture. Like it can be a very complex layer of neural network with some complex reasoning, and some layers as being depicted in this pic, right? So it can have multiple layers which does the processing, and then based on that it generates some text, right? So it tries to infer something. So when you give a prompt, it predicts what the next token or next sentences will be all about until it completes the answer. And it has the ability to fine tune as well as alignment. So sometimes if you don't like that answer, you can just mention that let's say I don't agree, or I don't like the way you answered. Just be precise. Or let's say if you are looking for some medical information or a legal information, you can say that you are a legal, think about it, that you are a legal assistant, or legal things and all. And using that also, it aligns using user feedback, and to make it more safer for LLMs to generate next tokens and text and all, and be more helpful. Now, the thing, tokenization that we talked about, right? So what is tokenization? So a text that we get, so just like hi there, how are you doing, right? So this text is split into smaller units that are called as tokens. These tokens can be words, it can be subwords, that depends on the large language model. Okay, for example, playing can be processed as play as one token and ing as other token, and then model processes this based on their vocabulary that they have, how they understand this text, and they generate text tokens and not the raw text. This can be simulated using the tick tokenizer app. We'll do a demo at the end of this session, right? So there is a nice app, tick tokenizer versal app, wherein you can select different models, and using that you can just find out. So for example, hi there, how are you doing, right? So if we look at Google Gemma 7b, this interprets this as 9 tokens. So it understood hi at one as one token, space there as one second token, comma as the third token, and how as the fourth. So just like that, it mentions this thing. While if we look for Microsoft Phi 2 model, the same text is being taken as using 8 token count, right? So it tries to convert it into 8 tokens. um, just a sample example is ColdFusion is represented by 3 tokens in Google Gemma 7b model, and 4 tokens in GPT 3.5 Turbo. So that's the difference. Every model has its own vocabulary. As a matter of fact, you can try for the following tokens and visualize the vocabulary itself as well. Like amoxicillin is a complex word. You can understand, how many tokens it's going to break it into. And similarly, a numeral value, which is a double kind of value, you can interpret how it's being processed. And a complex name itself, you can see just, and we are going to see some of these at the end of the session. Yeah, I'm going to cover the demo at the end. So we understood this fact that LLMs are able to answer, but we should think about, we should have a decent understanding of how they are able to answer. How is it like we are providing some text or some sentence, and they are able to provide us with the next set of responses and all. So LLM goes through a very complex process. So in which first thing is pre-training, then tokenization, and then neural network training, that we talked about earlier as well. So pre-training, generally what happens at this, what it does is, like, basically it tries to process the web corpus, right? So from the web, it extracts out all the URLs, and then let's say if we are going to train a model which is only specific to English language, so from the URLs we'll remove those URLs which are having, let's say, Hindi, or different other language, or a Chinese, or so those URLs will be removed. So from the URLs, the text extraction is done, then language filtering is done, and then it goes for some deduplication if the same content is being present at multiple pages, so that thing is being done. And then there are some custom filters as well, and then there is PII, like personal information, if you want to remove, right? That should not be used for training. So all that complex things are being done, and this is the data that we get. And after that, this whole data is being tokenized. So how tokenization is done, that based on the model, how its vocabulary is all about. Like pre-process can be two different words, pre and process, in one model language, or it can be a single word in another model. So the text is converted into sequence of symbols, some kind of machine code. And then based on that, let's say if we have 5,000 text characters, then it can take 40,000 bits with the vocabulary of size 2 tokens, bit 0 and 1, and 5,000 bytes with a vocabulary size of 256 tokens, like bytes as value. Now in neural network training, what happens, right? So it goes through all the complex corpus and all, and it tries to identify the next word. So let's take this as an example. Let's say this is a simple example of 4 tokens. So like we have this operator, then viewing single, and we want to predict what will be the next text or token all about, right? So the way it's going to process is that it converts it into a token number, which is like 91, and view is 860, and based on that it identify what can be the next set of tokens that can come in. Okay, so if we see in this, it has a probability of more than 1 lakh, right? So almost 0.1 million of for the next token. And out of that, like the word direction probability is like 2%. It has a score of 19438, and the probability of word post is like 4%, which is 3962. So like I said, I mean, when it has processed those corpus, it has met viewing single post as much many times as compared to viewing single direction, and then viewing single case, right? So that's how it tries to generate or predict what next text will be all about, and based on that it identifies, right? Now it's not that it's going to predict only a single word. It can be multiple layers that you can take 2-3 answers and simulate it, and then accordingly simplify. So large language models, and then what happens is, like, basically, let's say we have this sentence, so we try to simulate it with an example. We have this sentence, we tokenize it, so the tokens are being generated, have the bards who proceeded, and then we represent them as token embedding vectors, and those are nothing but some numeric representation of the tokens, which can capture their meaning very well. Okay, and I'm going to explain that why we are going for vector creation. Okay, and after that it gets processed into the language model, and then after that it tries to predict what will be the next language tokens, or embedding vectors will be all about, which will be converted into tokens as well, right? And we are going to discuss that why converting it into vectors, and then accordingly trying to extract meaningful information and converting back to tokens, these steps are there. So first of all, embeddings, like we mentioned in the last slide, right? So what embeddings are? So embeddings are converting these tokens into vectors. Okay, and what we mean by that is, like, we convert them into vector representations so that we try to find out the similarity. So similar words should have similar representation vectors. So if you see here, mathematics and statistics, if we think about from an aspect of subjects, it's a totally different subjects, but basically they are related, they are very close in the vector space, right? So the vector score that is being generated, the corresponding vectors will be very close to this, right? So because these are similar words. Similarly, tiger and lion in the vector space is going to be very close to each other. So the smaller the angle between these two, the more similar the words would be. Okay, and like we can understand, right? So we have certain other words like rabbit. So a model that is being trained, which has certain aspects, like it tries to identify, it tries to take mammal as one feature, rodent as another, gender as another, right? All these features. So it's going to give a probability. So like rabbit has a high probability score for a mammal. Okay, but if you see hutches, it's very, like, it's minus zero point 0.3. Similarly, right, like if we take mother, so it has a high mother and woman and all, right? So they have high probability score for gender. So that's how we are just trying to represent them in a vector space. Now we talk about vector space, right? But vector is a complex representation. Okay, so most of us are familiar with relational databases and all, but for processing vectors, we do have specialized vector databases, which are known as vector stores, and these are specialized databases that are designed to store and search vector embeddings. Okay, and those can be numerical representation of text, it can be for images or other data that is used in AI and ML, right? And it supports similarity search, it returns relevant content. Some of the popular vector stores are ChromaDB, Pinecone, Milbus, Qt. And if we see here, right, there is in the right hand side, we have a diagram wherein we have the concept of dedicated vector databases, which comes in the form of Chroma, Milbus, LansDB, Qt, and all. We have some relational databases as well, which support the vector search, like PostgreSQL is the closed one, which has that, though it doesn't support all the functionality, but still it's there. We have Cassandra databases. We have some databases which are commercial or where source is available, so like Pinecone and Viviet. And similarly, we have the other databases like Elasticsearch, and also all these can be used as vector stores. Now coming to prompt, so prompt engineering is very necessary for LLMs to understand how they are going to actually provide the responses, right? So prompts is basically an art of crafting inputs to the LLM to get useful, accurate, and reliable output from LLMs. Okay, and there are common prompt engineering techniques. So something that is called a zero shot, wherein you just ask the question directly and expect an answer. Then few shot, wherein you try to provide an example that, okay, I have asked this question and I expect the answer to be this one, and then ask another question. Then there is a chain of thought, wherein you ask the model to think step by step. Then there can be role prompting, wherein you can assign roles to the LLMs, like you are an expert doctor, or you are an expert legal advisor, those kind of things. And then we have format enforcement as well, so that, let's say, the response that we are getting, if we want the response as JSON or a PDF or a slide or an image, we can mention that. and then some instruction tuning that you can use precise verbs like list, or you can explain that in detail and all. And similarly, the prompting techniques for summarization into persona, that is identity, where you specify that you are an expert in large language models, okay, and if you want to give some instruction, let's say summarize and all, so that is there. Then context, that in what context you want to talk about, whether it's like physics or some additional information that you want. Format we already discussed. Audience, for whom I want this answer. Then the tone, if you want the tone to be professional and clear, and so all these kind of. So we are going to cover some of the techniques here. So let's discuss about the zero shot prompt technique, right? So let's say I have this query that classify the text into neutral, negative, or positive, and the text information that I'm asking is, I think the food was okay, and I'm asking for the sentiment. So here I've not provided any example. So this is called a zero shot prompt, and it's going to answer me with a certain sentiment, right? Whether negative, positive, or neutral. Okay, in one shot prompt, I gave an example. So let's say classify the text into neutral, the similar prompt example that I gave. Okay, I gave one example here that I think the food was all right, and for me the sentiment, this sentiment is neutral. So let's say then if I again ask a question, I think the food was okay, right? You should give me based on this understanding that if I thought okay, all right is neutral, then what should be okay, right? So this is like where we provide an example. Few short prompts is basically where we provide multiple examples. So here if we say all right is neutral, great is positive, horrible is negative, then what will be the sentiment for I think the food was okay, and it's going to reply like neutral, right? So that's where we give more example. Chain of thought. Yeah, so chain of thought is a very interesting standard prompting, and basically it came into a picture because at the time when earlier the models were released, it was answering some wrong uh, responses. It was giving wrong responses to some of the questions as well, right? So like if we have Roger has 5 tennis balls, this is the question, and for this the answer, if we see, right, 2 into 3, that is 6, plus 5, that is 11, right? We give that, and then we again ask this question. So this is one standard prompting that we give, and in this the correct answer should be 9, because out of 23, 20 apples have been used, and after that 3 is remaining, and after that 6 are added, so 9, but the answer that the model was giving is 27, right? So then in chain of thought prompting, what usually happens is you try to explain it to LLM that when I give this question to you and I said answer is 11, how I derived that information, right? So there is where I have given some example that Roger started with 5 balls, 2 can of 3 tennis balls, each is of 6. So that means 5 plus 6, that is equal to 11. So then if I ask this question, it also derives in a similar manner that cafeteria has 23 apples originally. They use 20, so 23 minus 20 is 3. And then they bought 6 more apples, so they have 3 plus 6, 9. So that's how. And sometimes what usually happens is that basically, LLMs also try to answer through memoization, right? So they don't use, so wherein you can give some kind of prompt that use code, use equations. So in that scenario, it either invokes a Python library or some function that it has, or it tries to derive an equation and write, wherein then it can provide the correct answer. Now RAG, right? So yeah, first we'll discuss about the motivation behind RAGs, why RAGs were required, okay, why this technique was developed. So the motivation behind RAG technique is that the LLM's parametric knowledge is limited. Right, there should be a way for LLMs to answer queries outside of what they are being trained. So, for example, let's say an LLM which is solely trained on medical data, okay, and I want it to answer a mathematical question or something related to subdomain of medical, which it has not been trained on, right? So there should be a way wherein I can ingest that data somehow, and I can ask LLM to answer from that data. Then RAG allows users to perform Q&A on private documents which can't be shared outside, right? So sometimes there are necessary use cases wherein you don't want to share the private documents to the models. So what you want is that these private documents with me, and I want to train my LLM on these private documents, so that the LLM should be able to answer on these documents. So That is one of the use case. Then the third use case is that, let's say that the data set that is used for LLM training are out of date. So some LLM which is being trained in data till, let's say, 2022 or 2023, and we try to ask what is the latest iPhone series, and then it represents like iPhone 12 or 13 because it was being trained on that data, right? There should be a way to train it to the next level or with a recent data. And the last reason is that the context size of LLMs are bounded, right? Though the present day LLMs support 1 million contexts, however, it's still not adequate for many of the use cases, right now. So these are the motivation behind using RAGs. So before even going to the technique of RAGs, first of all, let's try to understand the an important concept which the LLMs use, which is known as Euclidean distance and cosine similarity. So Euclidean distance, I think every one of us might be aware about that. It's a straight line distance between 2 points, so like A and B. So it's like if it's a two-dimensional space, then by 2 minus y1 square plus x2 minus x1 square root of that, right? So all this, and this is being used when we need absolute similarity like images and all. But cosine similarity is more about when we want to measure the similar words, like the example that we gave, like something that might be valid for mathematics might be valid for statistics as well. So in that case, though mathematics and statistics are not absolutely similar, but they will be close when they are being represented using vectors, right? So to measure the similarity, we use the concept of cosine similarity, and what we do is we create the vectors, like we represent that in the vector space and try to identify the angle between them, and the less the angle would be, then the more closer that would be, right? So it is being used in text and vector similarity. It is also being used in RAGs as well, and that's why we wanted to discuss that. Now, coming to the architecture of RAG, right? So, a RAG system, it's a bit complex system, but it has individual subsystems as well, wherein you can, everything is described as a layer, which you can tweak to optimize the RAGs itself. So there are various components. So first component is document loading. So something like private PDFs or data that you have, or a web corpus that is being newly developed, okay, which was not their website data, some personal data that is there. These are all our document corpus, okay, and we need to load these documents. Now in a RAG system, once we load these documents, we need to split these documents using certain algorithms, right? So basically, because the documents can be huge and LLMs cannot process it one at a time. So what it does is it tries to split it into multiple sentences, or based on paragraph, or based on words, or something related to, let's say if it's related to Java code, then based on function level, comments level, or class level, the way splitting is being done. And after splitting, it is being tokenized, and that tokens are being generated, converted to vectors, and that information is being stored in the vector store, right? So all these documents information, because this was not available to the LLM, so we store it in the vector store. Then we ask for a user query, right? Like we want LLM to answer a user query for which LLM doesn't have any knowledge. So what happens is that when the user query is being issued, then for that user query, using the same algorithm, we generate the embeddings for that embedding vectors, right? And we tries to match from the vector store what are the relevant splits which matches this corresponding embedded or vector representation of this query that is there. We try to find out those relevant splits, and then we make a prompt of that. Okay, so in prompt we can identify that whether you need to be very precise, you need to answer it in one paragraph or something like that, and based on that it is being sent to LLM, and once it is being sent to LLM, then the LLM answers that question. Okay, so that's how RAG system works. Now coming to the first step, splitting and chunking, right? So splitting and chunking can again be done through multiple algorithms. So one is character based splitting. Basically, it splits based on character. Then it can be a recursive character splitting. That is, it can split on multiple delimiters like comma, semicolon, new line, space, and all. Then it can be document specific splitting. So something like class level, function level. Like if you are trying to process a document which is concerned with the code, you can provide function level splitting or class level splitting. It can be semantic chunking. So in semantic chunking, what happens is you try to split it into multiple sentences, and then you try to combine three sentences and process it as a one chunk, because let's say three sentences will be very small, okay, to process and all. And then we have the concept of agentic chunking, which is we use LLM to chunk by prompting. So we give some prompt and it basically creates those chunks. Okay, we'll also go through this demo of how the splitting and chunking works at the end. Now, we talked a bit about RAG. Let's also talk about that RAG do have limitations as well. And the kind of limitation that it has is like first is dependency or retrieval quality, right? So if let's say the web corpus or the data that we are giving is poor, right? It's not relevant at all, then the answers that will be provided for the prompts or for the queries will be also not great. Okay, then there can be chunking trade-offs. So basically, if uh, we create very small chunks, then we lose on the context of the related sentence, and if it is too large, then it can exceed the token limits of the LLM. So we need to be very cautious about that. We need to apply some heuristic approaches and try to identify that what should be the chunking size, how much should be the overlap and all. Okay, and then the latency, it incurs a latency as well, because here the information is being stored in the vector store, and there's a specific process that is being involved, and hence it is slower in the direct LLMs because it needs to process that similar vectors from the vector store. And then there can be augmentation hurdles as well. So wherein let's say there can be redundancy in the sense that similar information or similar repetitive responses that we are coming in from the RAG, right? And yeah, most importantly, it doesn't learn from any feedback. So it's not that let's say if something is wrong, it can just adjust or update the embeddings or documents with the knowledge automatically. So these are the kind of limitations that RAG has. And similarly, the research have happened and new paradigms are coming in. Let's talk a bit about advanced ragging techniques, right, that we have. So to filter out or to encompass all these limitations, some advanced techniques came in. RAG is a multiple step process, right? So to enhance RAG steps, each of the steps can be improved independently. So one thing that we can do is metadata to enhance RAG quality. So something like you are looking for latest iPhone series, and when you are ingesting the document, you can ingest that. Let's say, okay, iPhone 16, it got released in let's say 2025. So you can tag it with year information. You can do chunk size optimization. You can do parent document retrieval. So basically, if the chunks are being splitted, so in this parent document retrieval, what happens is that the original document is being splitted into multiple chunks, and then these are again splitted. And let's say out of that, it's let's say my embed 4 is the closest embedding that the query matches, so it returns the chunk 4. And I want to return more context, right? So I'll take the full paragraph like parent chunk 2, which consists of chunk 3 and chunk 4, and I'll return as such, right? So that was also a technique that was adopted. Then multi-query retriever. So in this case, let's say for certain queries, if the LLMs are not providing certain responses, proper responses, then we can use another LLM to rephrase that query. So it creates the query which it thinks can lead to a better response, right? So we can use that technique. We have step back prompt technique as well. So in this, what usually happens is something, let's say if you are looking for a problem related to physics, okay, and which is including Boyle's law, so you can mention that in a step back prompt that try to solve this question using Boyle's law. So in that case, the machine or the RAG gets in enough information that okay, I need to answer this from the perspective of Boyle's law. And we can do a hybrid search retrievals. So while returning answers, we can do a vector as well as keyword search, and then we can re-rank to get more better information from RAG. Okay, and another thing is data cleaning. So data cleaning is a very important aspect, and it has that step of replacing pronouns with nouns. So specifically, if we look this example, right, that Mayank Yadav's IPL debut has been remarkable with young pacer from Lucknow Super Giants, okay, securing consecutive player of the match awards. And then the 21-year-old exception pace as he surpassed his own record of this much for the fastest ball of the season, unleashing. So if you see, let's say if my chunking or splitting is being done in this manner, that the red is one chunk and the black is another chunk, and if I try to answer for query for information who bowled the fastest delivery, right, in this match, so So in that sense, LLM or the RAG is not able to answer because the context is totally missing. It doesn't know the name of the person because the splitting is being done. So in that case, what we can do is that, say, instead of 21-year-old, we can use Mayank Yadav again. Okay, so that when it processes that information, it will be able to answer that he's the one like who bowled the fastest delivery. So that's how different techniques are all about. Now, we talk about LLMs, we talk about generative AI, we talk about prompting, and even RAGs and all. One thing that comes into everyone's mind is how can we use ColdFusion to interact with LLMs, right? So if we see the ecosystem to interact with LLMs, it mostly consists of rich libraries that have been developed in Python mostly, okay, and which are very easy to use. Apart from Python, there is LangChain 4J also library as well, which provide libraries in Java, using which a developer can interact with LLMs, vector stores, etc. Okay, and we know that ColdFusion application can also interact with LLMs using CFSTTP and CFJava tags, because inherently, some Java library that is already there, we can use ColdFusion language to invoke the Java related code from that. Okay, and for querying LLMs, the developer can invoke the corresponding API for LLMs using appropriate prompts and get the responses using a CFSTTP tag. And for for the scenarios where developers who are interested in ingesting information into the vector store, right, they can use the CF Java tag and invoke the corresponding API of LangChain 4J. So that's how some information we can ingest and ask the LLMs to answer those. So yeah, so basically there is a demo that I have, okay, and uh, so this is the demo wherein I'm going to discuss about. But first, let me explain. Let's go through a bit of demos or codes that we had. So first thing that we had is this tick tokenizer, right? So in this is a very nice app wherein you can select different models. So let's say Google Gemma 7b, and here if I ask for this information, hello, how are you doing? Okay, so if we see, it is being represented by 7 tokens. Hello is considered as one token, and it's not actually hello, but it's a space or the start of sentence and hello. So that is being represented by these 2 tokens. Then how is space and how is being represented by this token, r and this, right? And if we similarly select another model, right, Microsoft Phi 2, that is only representing it using 6 tokens, right? And we can similarly see that what ColdFusion is represented by. So ColdFusion, if you see, it is being represented by 3 tokens in Microsoft Phi. So cold is 1, then F is second token, and Usion, USION, is considered as third token, and these are the corresponding token numbers that are being assigned. If we took in Google GPT 5 3.5 turbo, how much it takes, so we can see it also takes 3 tokens, right? We can go for another token here, and let's say same. So if you see, it also takes the 3 tokens. So that's how you can play with that. Now coming to the chunk visualization demo, and yeah, just make sure that you have this URL, and I'm going to just mention that in the chat window as well. But basically, this we might use for quiz as well for today's session. Then chunk visualization, right? So basically, the text that we had in this. So let's say this is a sort of whole corpus or a text that we are going to split, and then we can use multiple recursive test splitter with certain delimiters and all. And for this sentence, you can see the chunk 0 represents only this portion of the data, has chapter 6 and what sort of depth is democratic, right? Chunk 1 represents another some space, and chunk 2 represents this I had remarked to this thing. And then what we can do is we can also alter the chunk length to totally split the data into different, right? So these are another way of which you can do. And we can use LangChain character test splitter to split the sentence, and it will be a totally different technique of how splitting is being done for these documents. Okay. Sorry. Now coming to the RAG demo, right? So in this RAG, what we have done is like we have created a prompt we have taken. So there is an AI system. What we are going to do is we are going to simulate two scenarios. One scenario is that we have certain documents that are being stored here, okay, in this. So these are some of the PDFs that are being there, and most of them, if you see, like you budget speech 2025. So first of all, let me show you what the model that I'm using. So I'm using Ulama 3 model. Okay, Llama 3 model. And let's say if I ask that information till what year data you are trained on. So it will probably provide something like 2023 or 2022 till which it has been trained. Okay, because um, okay, it gave me totally different answer. But basically when I asked for latest iPhone series, so if you see here, it gives as of September 2022, right? So it doesn't go beyond 2023 and all, right? So that's why it's asking something like iPhone 14, iPhone 13. That's how it is, right? So it doesn't have that information. So what I did in my RAG is that I've created some of the documents. So in this documents I am giving some information about, one is like budget speech, okay, which is the Indian budget for year 2025. And then we have given some other documents related to Firestore and whatever the newly released information. Okay, so if we try to ingest these documents and try our RAG to answer the queries based on these documents. So first of all, before answering that, I'm using this machine. Okay, let's ask a query which is basically I'm just going to ask to this LLM what are the current tax slab rates. Okay, and it gave me some answer, right? The current fiscal year, this is what the, so it gave me answer from 2022 2023, but I want information related to 2025. So for that, what I did was I ingested these documents. Okay, let's go into the RAG demo, ingest data. And in this, what usually happens is that you try to first of all get an embedding model. So for the simulation, I have used a very simple in-memory embedding model. And then we try to initialize the embedding store, which is an in-memory embedding store. You can also use ChromaDB to ingest this information, but in memory would be much faster. That's why I choose that. Okay, and once I have that, then after that I just what I did was I'll try to initialize my AI chat. So the documents I'm trying to ingest and I'm trying to query them. And the chat language model that I'm doing is that I'm using Llama 3 model that I have run, and in the console what I was showing, I'm trying to use that LLM to answer. Let me execute this chatbot once. Okay, so let's say it runs, and it will provide some it will ask for query, and we are going to give the same query that we asked for from the Llama 3 model, right? And let's say it's asking for hello, ask me about the components. Okay, and I'm saying that current tax slab rates, let's say. Okay, and so it has ingested that information from the documents, and then it is trying to find information and see the information that it gave. um, I'm happy to help you with the query. And current tax rate slabs are nil tax for income of up to 4 lakh, 5% from 4 to 8, 10%. Okay, but is it the same? It's not, right? It's different. And from where it has taken that, it has taken it from this document which I tried to ingest it, that is from a budget speech, right? 4 lakh rupees, it should be null, and 4 to 8, 5% and all. So it has given this from that document. Okay, then I can maybe ask another question. Let's say first, let me ask Llama client, right? How to use GraphQL in ColdFusion. This is because it's being newly released, and the information with which it will give content like information is not related to. So it says something like, uh, some library that you can use, set up an external GraphQL server, and you can use CFML to GraphQL. You can use using CF set schema. Now let me ask the same question to my RAG, because I have ingested that information. Okay, and let me put that in this query, how to use GraphQL in ColdFusion. And it's going to provide me some information because I have ingested this GraphQL, ColdFusion. So it gives me this sample example that, according to the private provided information, here is what the steps looks like. Install the full version of ColdFusion and the GraphQL package, location of GraphQL files and all, and it tells you the corresponding APIs, what are the query and query parameters, a sample code snippet also, and all. And it also mentioned that please note that this information is sourced from the GraphQL in ColdFusion 2023 document. So it is basically this document that it has used, right, for processing. So it is not taking it directly from model. So that is one thing. Now all these steps that I mentioned in my presentation, right, so these all are configurable. Like, splitting, for splitting I used text based splitter. Okay, so you can like, there is this function wherein I'm processing and I'm checking, let's say if it's a PDF file, then use PDF document parser for that, or else a text based parser. And in this also, you can split those documents using a document splitter with a maximum character size of 1000 characters and then overlap size of 200. Okay, so this is one kind of simulation where I try to ingest some information related to some documents, and I'm trying to answer the queries related to this. I'll take another query, how a budget looks like for middle class. Okay, and this is all not directly available from the document, but it tries to infer based on the context it has. So the kind of answer that it is giving is not directly searchable in the document itself, right? So it mentioned this thing, that according to provided information is a small summary budget middle class. So it gave the same information, and the middle class will not have to pay any income tax. So all that information it has given. Now one thing that is very important here is that, I understood like I explained you the concept of embedding vectors as well, right? So let's go into an understanding of how uh, a vector looks like, right? So let's say we have this user prompt, which is current tax slab rates. Okay, and I am trying to get the data related to this. And let's say I'm trying to get the information of what kind of vector has been generated. Okay, so let me stop this, and let's see how the vector generation looks like for this prompt, right? Current tax slab rates using one model. Okay, so here I executed this, and then if you see, so this is how the embedding vector looks like, right, for this, because it generates and it matches it according to the documents. And if you see this uh, vector itself, right, so it is like huge vector, right, consisting of some probability scores. Probably it depends on the model size as well. So it identifies the probability, and based on that it has identified those metrics. Okay, so that's how the vector representation looks like. And for more complex representation like model, the vector would be vector representation would be very complex as well. So for example, if I try to use an embedding model, which is like if I try to use not a small normal embedding in memory model, but the llama 3 model, right? So let's try to see how it looks like. Okay, now I'm using the llama embedding model, and let's say if I try to use that, and if I try to identify the vectors here, how the vector representation of the same text which I gave as an input, which is current tax slab rates. So it will take some time, and then it will provide, because llama is a bit of complex model, right? So it will take time and all. So I think it's, yeah. Meanwhile, up till it generates, let's move on to the presentation aspect. I'm going to cover. So just that we have all these steps identified. We have identified a model, different query embedding models and all this thing, because it's just a Java code. We can just put it in our CF app. So our app will look something like this. Uh, Yeah. So all this information, I can just put this Java code. I can just put using the CF Java tag, or using Java code into my application.cfc, and then I try to find out, and I can query it using a UI, and a similar UI that I developed, and the demo is as shown. So it can be a chatbot, and let's see how it works. So this is something, right? I asked for the same information, what are the current text wrap rates, and it gave me this answer just by mentioning. And then I'm again asking another query like GraphQL in ColdFusion, right? And I'm just submitting, and it's again going to query the model and then try to find out. So it gave me this response of that, how a GraphQL code snippet, or how can you use GraphQL uh, using ColdFusion. And then I can ask for another query, okay, like using GCP in ColdFusion. And then if I submit, it's going to again query that information from the RAG that I have developed, and see it's able to give that thing, right, based on the documents provided, and how that is there. Okay. So yeah, meanwhile, the information, yeah, came in, and so let's see how the vector representation using llama models looks like. So see how deep the model is, right? How many number of parameters, and also this vector is huge, because llama language model has its own number of has more parameters, and it has generated probabilities. Now let's take another demo, in the sense another scenario, wherein what I'm trying to do is just 1 minute, yeah. So instead of yeah, so instead of documents, let's try to simulate a bit of URLs as well. That So what I did in this is, let's say I've given it some information related to Apple iPhone 16, and Wikipedia, uh, like Samsung Galaxy Wikipedia, iPhone models, and all GraphQusion, ColdFusion, right? Some HTML pages that I have given. So it tries to parse using an HTML parser and ingest that information. So first, me ask for this information directly from Llama model, right? So let's say if I ask for this, what are iPhone 16 prices? Let's see what Llama 3 answer. So it says that as of my training data cut off in 2022, the iPhone 16 series has not been announced by Apple. The latest iPhone series available is iPhone 14. So it doesn't have that data. But what we can do is we can ingest that information, and using these websites that we have, like iPhone 16, and let's try to get this thing answered. Okay, so let me run it. Yeah. So, so for example, the query that I gave, right? I mean, it parses some of the documents, and let me ask iPhone 16. Okay, and based on some document, it says according to Apple website, the prices for iPhone 16 starts from 6250 per month for up to 12 months. So it basically went through this source. It tries to query that information, it tries to process that, and using that, at least it's able to answer which cannot be directly answered by. And similarly, let's say, let me ask another, vague question where I feel the answer should not be there. So I made something like, Galaxy Y model series does not exist, but I'll still ask, like, let's see how it answers that. So let's say if I again ask for this, what are top end Galaxy Y series model? Let's see how it answers that. So it basically knows that there is no such thing as Galaxy Y series. The information provided mention various Samsung smartphones, yeah, including Galaxy A, Note, S, MF. So all those things. So it basically it's able to provide that information. So yeah, so this is what, and once we have developed this code, it's a very simple. And what you can do is, let's say those examples that we are giving, okay, we can change the message prompts as well. So basically, let's say if I don't want to use this prompt that I said, right, I can change the prompts to something else, and you can see how the answer will vary. So let's say, again, let me ingest that document. Okay, and we'll see a difference in how the responses looks like now since we have changed the prompt. So I asked about any information about Galaxy S25 Ultra. Let's see what it gives. There's no information about Galaxy S25 Ultra in the provided context, right? So if you see how specific it is, let me take another prompt where which I used earlier, so that it was providing so detailed information, and now how it will just provide it in one line. So that is because of the prompt. Okay, so it just said the budget appears to be good, and it is very specific to this thing, right? Earlier it provided a lot of information of how it looks like, then the tax slab rates and all. So this is how you can use, basically this is the Java code, and you can just put it in CF Java tag here. You can put your own keys as well to query the different language model. Like if you want to use OpenAI chat model, you have to provide your OpenAI key, then the model name which you want to query. Here I'm using Olama chat model because I've hosted it locally. The text document parser, PDF document parser, there are different parsers. You can create your own custom parsers as well to process information. And then yes, there are different prompts to answer those as well, right? So all these things are there. So that's how, I mean, it's an interesting stuff, but basically it requires a bit of patience, and to look for, after ingesting these documents, what kind of queries are giving me good responses, what kind of queries are providing vague responses or not that great. So yeah, so that's how it is. And yeah, just before finishing this session, I would also like to show you a bit about LM Studio. So LM Studio is this UI. Okay, and here is where you can search for different models using search. Okay, and once you have those models, these are settings, right? You can select a model to load. I'll use a very small model, let's say 5. Okay, and this is how it's being loading that model. Once it loads that model, we'll start the server, and let's say we can just check this, and then we have prompt, and let's say, who are you? If we ask this, so it gives a Microsoft AI assistant, so you can play it and it doesn't require internet. So yeah, that's there. And one more, it's like quiz time now. So I want to ask this first question: which database can be used both as relational database and vector store? Your options are ChromaDB, Milvus, PostgreSQL, Cassandra, and Redis. Okay, and yeah, feel free to answer in chats, and whosoever gets it correct will get a $100 voucher. So yeah, and these are some of the references that I have taken. One is, like there's a very nice talk by Tesla director that is deep dive into LLMs like ChatGPT by Andrej Karpathy. He has a very nice explanation in the video of how LLMs work. And then there is a good ebook as well, which is hands-on on large language models at Orally. And then there are some lecture notes for Anantraman Palakod. So from there also I've taken some references. So yeah, but it's an important, like interesting field to explore, and it requires most sort of questioning and understanding responses, and then reasoning how and why they are not working. Any questions that you have?
Hey Ashudeep, so there are some answers in the chat box. Do let me know if that is right. And
Yeah. So the correct answer for this is PostgreSQL.
yes, I think Benjamin N has gotten
Yes.
it right first.
Yes. Yes. So yeah.
Okay, that is right. And there are few questions for you.
Yeah, Phil Chrisman,
Which,
yes, vectorization. So basically, yes, we are converting it into vectors, like I explained you, right? That vectors that we have created. So I showed you in my this. So these are the corresponding vectors that is being. So this is for the user query that we gave. This is for a small model like local all mini 2.5 model, and this is the second one that I showed was for llama 3. So that is what, like, vectorization we are using, and that's how we are doing chunking. Yes, we are doing chunking. We are doing chunking through text based splitter, and I can showcase that code as well. So when I have split and embed document, right? So I mentioned a text document parser. So it can be a text document or Apache Box PDF document parser based on what files looks like. And I'm splitting that embedding document. So we have an embedding model. I can give you a bit of code walkthrough. So what I did was that the embedding store that we are using just for fast performance is in-memory embedding store. The embedding model that we are using is a small one, all mini LM6v2. We can use Llama as well if the machine supports and you have enough RAM and all, and provide. And there is basically the code for initializing different. So in one of the simulation I initialized it to the Llama model, but right now we are using, by default it is using all mini 6v2. Then this code just parses all the files from a directory that I have given. And then the embedding store, right now we are using the in-memory embedding store. We can also use Chroma or the other vector DBs that were there. So in that case, what will happen, that the vectors that we are creating, we can ingest it to the corresponding vector DBs and then query from them. And then we just ingest the data. And how we ingest the data is, we got the file path. From file path is basically the directory path. From that we are parsing all the files. We have this user prompt. User prompt is basically the query which we are trying to simulate. Okay. And then based on that we are just embedding, we are trying to embed that. Okay. And this was the embedding vector that I was creating, right? So the vector that I showed you, this, so this is coming from embedding search request. So if you see, so this is only for the query that I am passing. For that it is generating that. Okay. And then we are actually limiting our results as well, that we want only three results. Okay. And with a response score of at least 0.75. So there is a probabilistic match that happens with the text that we have given and the chunks that are there. And based on that it is doing. And based on that we are trying to get the number of responses that we are getting. And I have maximized it for two responses, because for the demo session, so it is giving two responses for simple queries. Like one is related to some chunks related to this, and the second is this slab rates. So one is slab rate and rates are, so this is with this probability that it has, and the other is with 0.84. So that's how we are doing. And yeah, we are using.
Ashudeep, I think the screen is not being shared.
Oh yeah, sorry. Is it visible now?
Yes, I can see that.
Okay, okay. So
Thanks.
just sorry, guys. Yeah, I just missed that. So, like I said, I mean, in my demo, this is what like the embedding model that we are using right now is the all mini 6 LB2 embedding model, because it's a smaller one and it can be processed easily. But like I showed when I was showing you the code base, right? Llama also we can use because I'm hosting it in my local machine, and that is where I converted the, generated the vector. Then this code get files from directory, it just gets all the files that are present in the directory. Embedding store, we are just getting the basic in memory embedding store right now. We can also use vector, this chroma db for this. You just need to uncomment this piece of code. And then we have this ingest data, wherein we get the folder path and the user prompt. And what it does is that, you know it gets the embedding model. So these are basic embedding store and all. And based on the corresponding documents, so it can be either text or pdf, we are choosing whether we want to go for text document parser or a pdf document parser. Then we go into the split and embed document. Okay, and here what we are doing is we are loading these files from the corresponding files using the file system document loader. We are splitting it using a recursive technique, where the maximum size chunk size we are keeping as 1000, and the overlap size, that is 200. That is just to get a context of, corresponding chunks that we have. And once we have segments, we are creating embeddings related to that. And embeddings, once we have created, we are storing them into the embedding store, right? And once we have done that, then this is the query embedding. So the text that I was giving, like, current text lab rates or something like iPhone 16 series, we are trying to generate the query embedding for that. We are just creating the search request to query from the in memory model that we have. Okay, by giving the corresponding query embedding that we have generated, we have limited the maximum results to 3, and then filtering it out based on a response score, so which we have kept the threshold as 0.75. And based on that, it has generated the embedding vector for the prompt query that I've just printed. And based on that, we are just parsing based on, so we have just outputted 2 response scores here. So that's how. And that's how, the code looks like. A similar code is for ingest html. Okay, so that is for ingesting html documents. So all of the things, most of the things remains the same, just that, the parser. And so here what I've done is I've used the HTML document URL document loader. And using that, what I did is I'm trying to extract the text content. You can also use JSOUP library that is there, and then accordingly embed them and then query that. So that's how it's being done. Uh, yeah, I'll just I Hugging Face. Okay, you mean the tokenizer? Yeah, sure. Let me share that. Uh, so yeah, this is the Hugging Face tokenizer, and this is the tick tokenizer URL if you want to get the model, how the chunks are being generated. And Dave, you have some question, I think. What is the URL? Okay, URL is done. What is the concept of temperature, right? So concept of temperature is basically the randomness. Okay, so basically if you keep temperature to be 0, so at any point of time it's going to return the same responses and all. So temperature is basically to create randomization in the responses that is there. So there's really no support for LLMs in ColdFusion itself, but can use Java for this, right? Yes, for now, but we are in process, and that is there in pipeline. You'll certainly get the support. But for now, what I meant to intend is that we are not blocked on exploring LLMs using ColdFusion. We can certainly do that. I still feel that the library for Python library is really nice, but Java libraries are also good, and it's on the verge of improvement and all. And using that, since ColdFusion inherently supports CF, using CF Java tag, you can definitely use it. Any other questions?